representative of the Vice Chancellor, DVC Commerce, DVC, FDC, Dean of the Faculty of Engineering and Architecture, Head of Mechanical and Maintenance Engineering Department, Registrar of the University of Sierra Leone, Fourth Estate, and all other dignitaries present, our honorable sponsor here and supervisors of the project. Good afternoon. As Kagi said, my name is Alfred Mbayo, a fourth year mechanical and maintenance engineering student here at Sierra College. Our being here today is not only for us to present to you LEONE VENT, which is a Salon brand mechanical ventilator. We will demonstrate to you how important this invention is to the pride of the whole country out there. The Western world is struggling to save itself from COVID-19. We have seen how medical infrastructure in developed countries have been brought to their knees, they've been exhausted, and we are in crucial need of mechanical ventilators. Even so, these are very expensive medical equipment. Although they are life supporting, of course, but they are very expensive. And for the level of earning of a common Sierra Leonean, and even the government as a whole, securing hundreds of these, I think, is not possible. Because it is nothing less than $10,000 per one. And of course, yes, there are many questions. How can we improvise? How can we have something that, yes, can serve its purpose, but even so, much cheaper as compared to the modern ones? All these questions and several other reasons inspired, of course, our sponsor, Engineer Amara Tunkara, to pour his little earnings into the projects. And of course, our supervisors also build strength. And for us as students who have been waiting to practice hands-on engineering, it has been an enthusiastic moment. And yes, with all the questions, we wanted to produce a mechanical ventilator at a low cost, but even so, high efficiency. And yes, we did our research. And according to the rapidly manufactured mechanical ventilator system specifications of the UK, and of course the LEONE VENT mechanical systems of the Massachusetts Institute of Technology, we brought up our design specifications. There are three modes of ventilating the patient. You can either do a pressure control mode, or a volume control, or even a dual control mode. But then, we said we want to control the pressure that is delivered to the patient. We want to vary the inspirational pressure from 0 to 35 centimeters of water, and the expirational pressure from 0 to 10 centimeters of water. And yes, we wanted to control the breath rates, the rate at which the patient breathes in 1 minute. We wanted to control the inspiration and expiration time ratio. And of course, we wanted to build a ventilator that could cope with the power problem in the country. We wanted to build a ventilator, of course, that could be manually supported in terms of technical failure. So all these specifications brought us on our toes, ourselves and our supervisors. We went to the drawing board and brought up a design concept. And yes, we designed LEONE VENT. LEONE VENT has the ability to use both oxygen and room air depending on the patient's need. If the patient needs oxygen in terms of crucial situation of the patient's health condition, then oxygen can be slotted through here from any supply source. It could be an oxygen cylinder, it could be oxygen concentrator, or it could even be the oxygen supply through the pipelines in the ICU. Now, you close the pressure regulator to gauge the patient's pressure now that you want to deliver. And now you adjust the switches here to the requirement of the patient, the time of inspiration and expiration, the ratio. After adjusting these switches, you are sure now that whatever you are delivering to the patient is exactly the parameters you set there. Whilst you were reading the pressure gauge there, and then you set everything. Finally, you switch off the ventilation mode and then try to connect this breathing circuit to the patient. switching off the ventilation mode, of course, the reason for that is that the machine cannot be operating whilst you are connecting the breathing circuit to the patient. You switch off the ventilation mode, and then you connect the breathing circuit to the patient, and of course, you switch on the ventilation mode again, the patient is sure to survive. Now, in case of technical failure within the device, you may not have the time to remove the breathing circuit and connect another ventilator to the patient. Maybe during that course, the patient may lose his or her life. For this reason, there is a manual support system for LEONE VENT. This is an ambo bag. In case of technical failure of LEONE VENT, you can just connect the ambo bag through these slots here, and then you manually operate this one whilst monitoring the pressure and other parameters. What happens outside here on this bag is exactly what the mechanism does inside the device. And of course, only a trained therapist, respiratory therapist or lab technician is allowed to perform the mechanism, the manual operation of this bag. The whole cost of LEONE VENT, as you see it standing here, is about 18,500,000 leones, which is about $1,850. Cheaper as compared to the modern day ventilators, of course. Modern day ventilators are not less than $10,000, as we saw what our government procured recently. It took us about 1 month and 2 weeks to assemble everything you are seeing. Struggled day and night, of course, and we were able to assemble this one. But now that we've known the components to be used, now that we've established the parameters, if there is funding available, we can produce 10 of LEONE VENT in just 2 weeks. We have the expertise and we have the brains. We are sure that LEONE VENT can surely save lives. We are not saying LEONE VENT is exactly as a modern day ventilator. We are saying in times like this, when we need ventilators the most, yes, LEONE VENT can substitute the modern day ventilator and the patient is sure to survive. Under the LEONE VENT project, we have designed a wooden extension, of course, and for this one, we are challenging the university. We want to see this one in the market. We want to see this wooden extension in the market. This one carries all the extension, the projector, of course, our laptops, and we can connect a goose, electric goose, and a heater to it at the same time, and it functions very well. Of course, the LEONE VENT is connected to it. So we are sure. There was a shield. So we are sure that the extension here can challenge whatever extension out there in the market. There are a lot of Chinese and Nigerian extensions around, of course. So you may buy 5 of them and then it just gets spoiled in 1 week. Here is LEONE VENT, the wooden extension attached to it. So this is now a challenge for the whole of the University of Sierra Leone. Are we sitting back and watch this? Or we are boosting up this invention to reach to everybody across Sierra Leone and even beyond? Yes? If we say, if we want to build a nation, we have to believe in our own educational system. And how do we show that we believe in our educational system? It's by supporting the product of our educational system. And of course, yes, we have the brains. Thank you very much.